Welcome to my channel. Today we're going to talk about vectors and scalars. So let's start by defining what each thing is. So a vector has two components, and it has a magnitude and a direction. On the other hand, a scalar only has a magnitude. Now you may be asking what a magnitude is. Well, magnitude is just any quantity. And I mean by quantity, it can be unitless. It can be in pounds. It can be in newtons, which we'll later talk about. It's a unit of force. It could be anything you would like. Charge, which we'll later talk about as well as we go into electromagnetic and magnetism. Electromagnetism, better known. So now, those are the concepts. A vector is a magnitude and direction. A scalar is just magnitude. Now you may be wondering what those things may look like. Some examples. Can be for vectors. We are going to say, for example, gravity. Gravity, we know that the force or that the magnitude is 9.8 meters per second squared, which is acceleration, downwards or towards the ground. Now notice the two components. 9.8, which is the magnitude, as we pointed out over here, and then the direction is downwards. Another example can be your GPS coordinates. You know how they tell you go 3 miles southeast and then turn left or turn right? Well, they're telling you a magnitude 3 miles, and then they're telling you the direction to go towards. Later on we'll work some problems. So, an example for a scalar, spelling, I'm sorry, apologize, is for example your car's speedometer. You know how whenever, let's say you start from here and then you try to go this way with your car. Not an artist. But if you go this way and you decide to go 5 meters per second, your speedometer will just read 5 meters per second. However, if you're also going in reverse, have you noticed that it also says 5 meters per second? So a speedometer doesn't tell you the direction, it just tells you the magnitude. That's the difference between a vector and a scalar. A vector has both a magnitude, which is a quantity, and a direction, either downward, southeast, at a certain angle, as you will work and encounter in future problems. And a scalar is just a simple example. A speedometer is just the magnitude. It just tells you a quantity, a number, no direction. Now, moving on and further developing on the idea of vectors. Now, a vector because it has both magnitude and direction, it will have components. And components is just a fancy word for saying the x and y component. For example, if I decide to draw, let's see, an x and y coordinate, this would be your y positive, negative y, positive x, negative x, and I decide to say there's a vector here, just saying 5 meters per second, as we were working with the car here, at an angle of 45 degrees. Oh, that's a really bad picture. So let's take this out and summarize it and the side. So again, 5 meters per second at 45-degree angle. And this is the x-axis, we said, and this was the y-axis. Now, if you notice, this vector looks pretty much like a triangle. So we will treat it as a triangle. So our 5 meters per second is actually the hypotenuse of a triangle. And now by using trigonometry, we can find the y component, or the y piece of it, and the x piece of it, given that we know the angle. Now you may be wondering how. If your trigonometry is a little rusty, I would suggest look up some videos explaining the why cosine and sine works here, but I'm just going to summarize it really quickly. So the sine of any angle, theta, is equals to the opposite over adjacent. In our case specifically, is y over, I apologize, it's opposite over hypotenuse. In this case, it will be y over 5 meters per second. So in order to find your y component, all you have to do is move this to over here. So now your y component is equal to 5 sine of theta, which in this case we know it's 45. That's your y. Likewise, with the cosine of theta is the adjacent over hypotenuse, which in this case would be the x over 5 meters per second. Again, you just move this to here. And if you have trouble following how I did this, I just multiplied it times 5 meters per second, multiplied both sides times 5 meters per second. Some algebra right there. So now here I have 5 meters per second cosine 45. And now those are my vector components. The y is 5 sine 45 for this specific case, and the x is 5 cosine. I hope this was helpful, and tune in for our next video on how to combine vectors.